Now, platform is all yours. Over to you, sir.
Thank you. Thank you, Dr. Ekta. This will be a little bit of graph theory will be there. And then a piece of the lecture will be on epidemic and the stochastic things, what you learned, that will be naturally used within the, how we use in the graphical network. So, and then I will be explaining on the hepatitis C virus this time today about the how we model the injection drugs and then the controlling of the the hepatitis C through the mathematical modeling. How the mathematical modeling can help to understand the networks, those who share the injections, all these things. Thank you. Let me start my slides. Can you all see the screen?
Yes,
Hello?
sir. It is visible.
Yeah.
Yes.
Yeah, it
Thank
is
you.
visible.
Yeah, thank you. HCV modeling, new approaches. HCV stands for hepatitis C virus. In fact, those who are, by the way, those who are writing still the question answers, not to worry, you all done well. We can resume that after this lecture. So, which of the questions generally asked for HCV is, which are the targeted individuals, whom to target, the prevention, how to target them, who are they? Generally, the questions asked by the governments are how to identify them, and then how to model their behavior such that we can control the injection, we can control the spread of hepatitis C, which is essentially through the sharing of the needles. So how that can be understood using the mathematical models, and then eventually make a policy of epidemic control. So far, there have been worldwide several modeling has been done to control, to understand the hepatitis C. Some of them are related to the community-based transmission of HCV within the communities, within the small pockets of the countries or in districts. If it is in India, other countries, the community level transmission, and then within the modeling framework, they try to build. Some of them try to build the regression type of models. That means these models would actually try to understand the association between the various parameters, and how these variables are associated, and then they try to bring a association between the independent variables and the dependent variable, and then they bring they try to estimate the coefficients of these variables, and then they form a regression equation, and they understand the behavioral. They try to predict which of the risk behaviors are more important to be monitored. Then the deterministic models, as we saw, the mathematical models have been applied. That kind of models you saw for HIV, and then there are these models have a dynamic in nature, and then also agent-based models. Some of you also asked that. So broadly, so far worldwide, various modeling groups have been conducted based on this kind of four questions, four type of model: community-based transmissions of HIV, regression models, and then the deterministic models and agent-based models. And then the basic hypothesis, what I have proposed in 2020, given all these four kind of things, they have asked this came up due to the CDC, Center for Disease Control. They asked, put a question. One of the scientists asked me if I can develop a mathematical model so that they can better understand the behavior of the individuals who are sharing the needles. Can we mathematically understand? So the one of the things, even though I could develop mathematical model, in this case I thought that some sort of probabilistic models would be more appropriate. And then these models would try to not only the probabilistic nature of the behavior, these models also try to understand the network among these injection drug users. So this article I will also share after the talk. This to all of you. This through this article I promoted a new approach using the networks and also probability within the networks. The newly proposed idea is as follows. We create a graph with n number of vertices and m number of edges. So here vertices means vertices automatically you understood that it's a individuals. So one individual is a one vertex. And the contacts between the number of contact between one individual to another individual within the injection sharing network, injection sharing group, they are edges. And each vertex will have subgraphs. That means each vertex will be having several attributes within that vertex. That is the demographic, clinical, social, and other factors. There could be many more. So, in fact, in the original article, I included genetic factors and then also the community factors, financial things, economic status. Many things are being incorporated. So, we try to build a model with vertices and edges. So these edges are depending on the network. The network formation is based on the financial status. So injection drug users, rich injection drug users may not interact with the poor injection drug users. Similarly, the depending on the gender, various things also contribute for the network. Hence, the new idea would be each vertex is distributed according to the number of each vertex is divided into the number of attributes or number of behavioral traits they have, and through that the edges have been formed. So given that given say GNM, usually the graph is denoted by, in a graph theory graph, GNM stands for the graph, suppose say, then GNM means n number of vertices are there, m number of edges. And then this graph, sorry, I don't know why today my slides are moving without my interference. Just a minute, let me see what's going on. Okay, it's in the PPTX form. Just a minute. Sorry, that was in PPTX form, PPTS form, slide form. That's why automatically they are being slided without my intervention. Yeah. So then the GIPIMI, that means graph with ith subgraph. So the bigger graph, once it is formulated, that bigger graph is being divided divided with several subgraphs. Subgraphs means a graph within a graph with a smaller number of edges. So GIPI stands for ith subgraph. There are many subgraphs, finite number of subgraphs within a graph. And these ith subgraph will have PIMI, whereas sum of all the PI is equal to again bigger graph N. Sum of all the ith graph will have p attributes or the traits, and automatically the all sum of all that will be n. This subgraph number or total number of vertices summing all that will be n. Similarly, all the subgraphs, then edges all together would be capital small m. That's why all this, the number of edges formed out of vertices, subset of the vertices, all the GNM, all the subgraphs will have the total number of edges will be matching with the total number of vertices of the subgraph will be matching with the total vertices of the graph. Similarly, the edges also will match. So we divided based on the traits they have. Suppose, you consider this is a network of the data. These are all positive individuals, those individuals who are positive, and those individuals who are negative. And this is a network. So the network graph, that means this is a two-way network. This particular individual, positive individual interacting with other individual, sharing the needle. And similarly, this negative individual, positive sharing the needles. So there is a chance of transmission. Here already both are positive, so no need of new transmission. Already they are both are positive.
So I have a question here.
Yes, please.
That here we have used bidirectional edges. So we could have replaced them. I mean, we could have modeled it as an undirected graph then.
Sorry?
We could have modeled it as an undirected graph instead of assigning the directions in both the sides. We could have modeled it as an undirected graph. So is there any specific reason to model it as a directed graph?
Directed graph here, in a sense here, these are individuals who are sharing the needle with this individual. That's why direction is needed.
Correct, sir. But their direction is towards both the sides. My point is, so we could have easily modeled this graph as the undirected one.
That means?
That means that, I mean, if I do not assign the directions here on an edge, it shows that I can make a move from A to B and then from B to A as well.
Yes. So these are all individuals. For example, this individual, this is actually the demonstration purpose only. This is not a real network. This is a demonstration like this particular individual is interacting with the 1, 2, 3, 4. 4 other injection drugs that particular individual is sharing the needle.
Yes, sharing the same needle or the different needles.
They are all sharing the same needle. Sharing means their needles are shared.
Needle is being shared. So therefore, my point is, sir, that we could have represented it as an undirected graph as well, without assigning direction, because eventually we are assigning directions towards both the sides.
Correct, because sharing, like A is sharing with B, means B is also sharing with A.
Yes.
They have a common needle to share. So it is not that they are offering to share, offering one individual and then that is being kept back. They all mostly the individuals sit together in a group and they share the common needle among themselves.
Yes.
So that's how the data says that it's not one individual is giving them the needle and is keeping back in the shelf. No. That individual is bringing the needle within a group. They're meeting as a group and they're all sharing the needles together.
Right.
And in that group, some of them are positive and some of them are negative.
Yes.
And they don't know their status. The thing is here, all the individuals are not aware of their status, but they are only sharing the needles. So the question asked was based on the sharing criteria. If one of the individual is having in that group as a positive, can we predict the chance of spreading into a network? Given that they are sharing without knowing their seropositive status. The seropositivity is not known in advance to them because they don't come to the data. I mean, it's not my own opinion. It is that the public health workers, when they go to them, they don't allow them to test the status. So how do we understand the behavior of that individual such that you asked a good question, so why undirected graph we may not understand in this case. I mean, we can theoretically put an undirected graph. In this case, the network is known, but their spreading mechanism is unknown. Because these 4 or 5 individuals are sharing each other, and this particular individual may be having a different network. Within a group, one individual may have the same group, and that individual might have injection, sharing the injection with other groups. That's why
Yes.
the total graph is spread across a city, across a country, across some other larger geographical region. And then can we divide them into the smaller graphs? So now, for example, here in this case, this bigger graph can be theoretically divided into the small. This is, imagine this has some larger n nodes, n is a large number. This is a graph and G and M. This one for the practical purposes, I just showed a finite number of individuals. But then, if suppose we break down into the smaller graphs with some mechanism of the because based on the pi and m, that is the attributes. Based on the attributes, somehow we divide them the subgraph, and then can we match the subgraph properties with the other subgraphs? One subgraph you decide, and then so that means here each of this circle here is actually represented by a cylinder. That means each of this node is divided by some attributes A, B, C, D, F, G, different attributes. And similarly, the same attributes may have the negative person also may have the same attributes. So based on the attributes in a sense, based on their own traits, behavioral traits, by their financial status, by their education qualification, other biological factors, and then the age, gender, many other social factors. If you categorize them, these each of the node is into the network and they're all network based on the edges are formed based on their different traits. That's the new proposed idea. So subgraph identification. Then two graphs G1, G2 are the two graphs constructed based on the two population surveys. So we conduct a survey about the networks. That kind of survey also done in India also now. Various groups are very good work they have done on the data collection and the network formation of the network. Very good research has been done. Similarly, other parts of the world also very good work has been research work has been done on to conduct. They conduct a survey in the population, and based on the survey among the injection drug users, they formulate a graph. So G1, G2 are constructed based on two population surveys. Then isomorphism of two graphs means that there is a one-to-one correspondence between these two graphs based on the vertices and the edges. So this kind of isomorphism, that we can use it for formulating the algorithm that can match based on the traits. For example, this article by Bonici, he came up with a nice algorithm when the large number of networks are there. When large number of networks are there, this kind of algorithms are used efficiently for creating the matching between the two graphs. If one graph is given, whether one kind of network in one part of the world among the injection drug users are given, is there any similar networks are there? Any other part of the graphs, other part of the graphs in other part of the world? Then this kind of matching algorithms can be used. One graph, take out one graph and then match with the similar graphs if there exist other graphs. Then whatever the inferences we bring from one subgraph can be applied to other subgraphs without having to collect again that kind of data. Then what did we achieve through this and I will send the article again anyway. So what did we achieve was the deep target intervention through this new kind of attributes and formulating a graph and making it subgraph. Targeted interventions can be the interventions which we want to target to specific groups based on the traits, based on the behavior can be introduced instead of a broader behavior for all the graphs, all the networks. So that's one advantage of through that. And then misuse of the resources. because we don't want to spend resources of the to intervention, like giving new needles to them, asking them not to share, or sending the counselors to them. These are all the misuse can be avoided by giving the proper targeted interventions. That's a new approach can be helpful. And then that's the impact of the new HCV modeling is, this is not by me. Someone, other articles published, they wrote that, the new kind of suggested this sentence is taken from the other articles published as it is copy pasted. So they say that attribute level information at the each vertex and described in the this article letter to the editor by the myself is interesting, and these new network structures can form. And in another same article, in a different article, they also mentioned that these new designs could control the could be used to control the hepatitis C from the uh, from the real world. Practically this kind of formulating a graph and making it subgraph and matching the subgraphs with the other parts of the world can actually control the hepatitis C. That's what has been promoted. And then the additional approaches, once this is a basic structure has been promoted, now additional structure is, the building a deep learning algorithm for over a large network. That means we need to understand the over total network using the deep learning. Let us see that. So additional, suppose you take this kind of additional observed, this is suppose observed network in a population, and that at time T1 is susceptible at node VA. This is a VA node as edges E1, EA1, EA2, EAM. These are all edges of the node. And these edges are having some of the uninfected edges, infected edges. You see that there are two kinds of edges are there, infected, uninfected. And this, again, the attributes are each in a node will have an attribute, and then that attribute would decide that the edges or decide the edges. So after a few weeks or a few months or whatever the public health experts want to introduce, after a few weeks, with the aim is to break this network and then control the pandemic, control the transmission of the hepatitis C. You see that here, this particular individual is, the chance of acquiring this particular individual is broken here. Similarly, this individual is not infected earlier, he's been infected, that means not been controlled. So that means recovered, those who are recovered, here this particular into recovery, and the new cases can be monitored using this kind of graphical networks and then understanding their graphical properties. Now, what you learned since last few days about the stochastic process, that how we can use that into this kind of modeling approaches. Suppose xn I comma j be the random variable describing the status of a node. That means here the outcome of a random variable is the status of the node. And then I indicates susceptible, j indicates the infected. So xn xn I comma j, that means the status of the individual at the nth time step, whether he or she is infected or not infected. So that can be Pij is again probability xn equal to xn plus 1 equal to j given xn equal to I. So at the nth time step, the status is I, n plus 1 it is j. Pij stands for. So I indicates susceptible, j indicates infected. So susceptible becoming infected, or after maybe infected becomes susceptible if you say Pji. So the third again the time step, if you see that these individuals, some of the individuals again another time step, these are again the infection is spreading. So that using this kind of networks at two and more places, we can compute the Pij from the various data. We can compute Pij, and then this Pij can be used to understand the transmissions at the population level. So similar, then that kind of subgraph can be compared with the whatever I explained previously in the previous slides. Once the formulation of subgraph is done, that subgraph can be used to match the similar kind of subgraphs from the larger network. And then this graph will have a stochastic framework also within the graph. Thank you. So now I want to stop here and then open the discussion like the questions they're asking. The realistic modeling, how we can make it a realistic modeling, and then I'll be happy to discuss this. So please take this as a the question answer session. I want to have interactive session. So the modeling based questions, whatever you have, I would like to show on the write the different models on the screen and then interact with you all.
I have a query here that
Yes, please.
what are those interesting network structures which were identified in this study?
Yes, there is a interesting network structures here. This particular, I have given a general framework here. I didn't have any specific data in this case.
Mhm.
But what you are asking is very sensible in a sense. In India, the most of the studies are confined to Punjab and Hyderabad region,
Okay.
and then the border areas of Punjab. That's where they according to the study, if I recollect, certain individuals of age. They are not having this kind of behavioral network has not been formulated there.
Mhm.
They find that age is playing a bigger role in the similar age group individuals within a 5-year network. They are sharing the injection with among themselves mostly. They are not crossing luckily the age barrier. That's one
Mhm.
of the important outcome according to my understanding. That means their network injection, those are sharing mostly confining within some same age groups within the 2 to 5 year range they given.
Okay. And sir, what was the size of the data set? I mean, how
That
much?
is small. Like unfortunately, the data size is only 500,
Okay.
500 to 560. So
Uh,
what they did was some of the international studies, they combined all the countries' data and then they made the sample larger.
yes. But then different countries might be having the different relevant attributes. I mean, something is
Correct.
relevant for.
Absolutely. You are correct. Absolutely correct. That's so all these things networks have to be constructed based on the localized population because we want to bring a policy at the local level.
Mhm.
You're right.
And since the size of the data set here is 500, so it's okay to update the probabilities in such a dynamic network. However, if we have larger number of the nodes, then still the things would be, I mean, that much efficient to find. I mean, getting the isomorphic graphs. Uh,
Yes, it is possible because we are doing deep learning. You are right.
yes.
Here the still possibility is there because the deep learning means the size of the data can be handled by the high performance computers. Not
Yes,
a
sir.
problem.
So I think, sir, these are two separate techniques. I mean, either we are using the Markov, this thing. Sorry, this. I mean, yes, Markov thing, Markov idea to update the probability, or we leave everything to the algorithm to update the probabilities on its own and work like a black box kind of thing. So, in the
Yes,
implementation of this study, what actually happened?
yes. In the implementation of the study, the deep learning has not been applied so far.
Okay, okay.
Deep learning is not applied. This is a proposal, and then the other researchers working in the area, you saw their statements. They
Mhm.
agreed in principle because when I published this article,
Mhm.
then other people followed up on that based on that article, and they wrote that this kind of proposals can be applied. They make more meaningful because when the attributes have a p, here each attribute, each individual node earlier only seropositive, negative. That's it. And now
Mhm.
they divide the node into various categories, and then
Mhm.
make the understand the graph. Then that can be possible using deep learning, so that deep learning algorithms can help to understand the larger network of the graphs, and they
Uh,
store the data, and the matching can be more simplified.
yes, sir. But then to
And
apply the
isomorphism.
Yeah, but then, sir, to apply that deep learning thing, we would be requiring the label data. So probably in that case, we should be knowing this thing in advance that whether a particular node is seropositive or the seronegative one.
Correct. That, yeah, the computer, we need to enter that data. I mean, the algorithm would not decide the status of the individual. That information we have to provide to the computer. You're right.
Right, sir. Because, sir, if the network is small, then a lot many libraries are available for the analysis of the complex networks, and
Correct.
probably here we could have find the strongly connected component SCC or the giant component using that network X library in Python, and there are other libraries as well to analyze the data. So therefore, I'm interested in knowing this thing that we can easily find the strongly connected component. I mean,
Hmm.
it is more or less same as the connecting communication classes you talked about this yesterday, or what was
Yes,
that?
yes, communicating classes. Correct. You're right.
Right, sir. So it is pretty easy to find the SCC, a strongly connected component in a directed network of the smaller size. So I mean, in this study, I don't find that probably you have found the in this the SCC. Rather, some other structures have been identified. So
Yeah, that is, you're right. I have not explored that aspect of the SECs. It has to be done practically. The data. This is the proposal. This is the method only, and they have to come up with tests because practically those working initially, when they asked me, the idea was whether I can bring a better model for the Punjab area for drugs. Like, this is practically they want to implement using method what I'm proposing, and they want to me to be involved in the project such that ultimately we understand the right kind of networks and the transmission can, because hepatitis C is very expensive disease.
right, sir. Right.
It will be 5 to 6 lakhs for the treatment. Sometimes they're very severe, they're very very expensive treatments. So that transmission can be controlled, and one individual sharing needle is more dangerous than individual himself keeping a new needle, and so it's more than the addiction, it is a sharing of the needle.
Right, sir. Sir, can you elaborate something about the data collection? Because in the network analysis, forming a network itself is a very, very tedious task.
Correct. What happened was smaller components. There is a earlier I also, before this, the reason they asked me was, before this I developed a model using the very deep mathematical, using the NPP kind of problem. I published an article on that article, the model called chicken walk model. That based on that, one can Google chicken walk model. That was based on the poultry farms, poultry region. The network, the how the within the birds, the poultry birds, you see that a lot of bird related infections are coming every year in various densely populated bird populations like Asian countries especially, and like Cambodia, India, Myanmar, and where the bird populations are so thick. So in that kind of situations where this method, some of the, not exactly this method, the more deeper graphical networks are applied, they can be monitored because there is the bird population is large, but poultry birds all together they live. So that kind of things are applied, and the video technology is being developed so that the idea is, when the birds get infected, they spread them among the cages within the poultry cages very quickly. And now the farmers get a lot of losses across the world due to the bird infections. On an average, they $5 to $6 billion loss every year farmers acquire. And there, the network graphs are being applied, and then those network graphs can be used to control one particular cage, whichever the cage birds are there. Then using video technology, that particular cage birds can be separated quickly, so that the spread can be controlled. So these kind of things are being applied there. They are known as chicken walk models. Myself and then the other uh, veterinary doctors. I collaborate with veterinary doctors. Those who have the poultry, they are professors of veterinary colleges. Yeah, that's then these kind of things. But when it comes to human, now they have to still conduct the survey, and the survey design parts are very good, but then the data collection has to be done. This just happened, you see, 2020, just before the COVID interaction started. Then after COVID, in all other diseases, the progress has been almost negligible because of the everyone focusing only on the COVID.
Yes, sir.
Suddenly, it looked like all the other diseases are gone away. HIV, hepatitis C, tuberculosis, malaria, all seem to be okay because we are not studying them.
Yes. Now the only problem persists is COVID only.
COVID, yeah, exactly. But you are right. I know one has to have focus more on the model. So the reason here is the participants actually don't have to just focus on the only the academic side. They can actually take up an extra step, and the fascinating field of you can contact with the nearest college, other discipline people. It's very important for the collaboration, interact with the people who are of outside the discipline, and then bring a newer perspective. And this also most of things I learned from during collaborations. I'm not a trained veterinary scientist or not a trained epidemiologist.
Thank you so much.
Welcome.
Sir,
Yeah.
this modeling that you have explained, is this network analysis?
Yes, graph network analysis.
Sir, for when we do such an analysis, what should be the minimum sample size, and what will it depend on when we sample size?
Yeah, minimum sample depending on the. It's a good question again. Minimum sample is a data dependent and population dependent, and the prior prevalence. That's called power of the what is the power of the calculation. So that will give you the sample size. That's a different story. But then mostly the factors need to be needed to be considered are prior prevalence of that data. But if you want to study the hepatitis C in a population, suppose we want to build a network of hepatitis C population in say city Lucknow. Then Lucknow, there might not be any hepatitis C cases, and then you come up with a sample. We say that we need at least a sample of 600 to estimate the network. We want to build a network graph. Then we may not get a 600 sample there. So prior to the study, a kind of a pilot study need to be conducted, ideally speaking, in the Lucknow region, and find out the prevalence of the hepatitis C, and then other factors, the age structures and the network structures, some idea. Then those all information need to be used to get a population level, what is the sample size to be there. Then from that's a minimum. Then within the sample, you have to have both positive and negative people. Then only understand the transmission between them. If you get everyone positive, then there is no transmission among them because already they are positive. If you get everyone negative, there is no chance of getting infection among them. Understand the infection among them. So all these things to study the design of the sample and the what level, a 90% chance or 95% chance, what level of significance you want to have. That's a different sample size calculation. But you are right. All that will give you a minimum. There is no universal minimum value for any study. Like examples on a human, on the animal studies like mice. Sometimes 6 to 7 samples also enough. They do the laboratory, 6 to 7 mice. They take it and they inject some sort of treatment on the mice, and then they try to compute the level of suppose a diabetes study on the diabetes. What they do, they take a 5 to 6 mice and they damage the pancreas of the mice. 5 6 mice taken and damage the pancreas. And damaged pancreas means what? The mice will develop diabetes. So they artificially damage the pancreas and then give the treatment to the mice, and they see whether the diabetes can be controlled among the mice, because you cannot get a diabetic mice naturally, because most of the animals are healthy, natural animal, not in the laboratory animals. Most of the wild animals, if you see that, they won't get any most of the health complications. So they damage the mice. So 5 to 6 samples are enough. So why I'm giving ranges for humans, for animals, within animals, the range of samples depend on the study. Hope I able to convince you something to some extent. Welcome.
Yes, sir. Thank you, sir.
So here you see that all of you, the PIJ I used in the study, network study. So the stochastic things, what you learn is applied into a graphical, not the stochastic component is not used in a stochastic model. The stochastic component is used in a graphic model, graphic network model. And this graphic network model has no stochastic component. They have vertices and graphs, vertices and edges. So these vertices, edges, and on that, and they'll have combinatorial mathematics will be there, and then on that you are applying stochastic framework, what you learned in this course.
Sir, can I ask one more question?
Sure.
Sir, you were also talking about how regression analysis is inadequate in comparison to this modeling that you have proposed.
Correct.
Now, sir, as students, sir, would you advise us to concentrate?
Sorry.
Everyone is taught as a basic course. So in the you said that regression is taught to all of us as we start statistics and things like that. Now, like the way the world is progressing, you would say that we should now concentrate more on these kind of modelings, and regression will become obsolete in the near future.
No, I don't think so. Regression is a powerful tool, still be going to powerful. The reason why I mentioned was something powerful doesn't mean that applied everywhere, can be applied everywhere. The reason is regression will give you population level interactions, population level associations. It would not give you the individual level association. But network, because suppose I say that some individuals in 15, say 18-year-old individuals in Amritsar using injection drugs nighttime. Suppose that's a conclusion based on the regression model. That means all the individuals of 18-year-old are infecting, are interacting, sharing needles at the night time? No. But regression cannot give any more better result than that, because it's a population level association. That's the reason I mentioned that population level association, when we need, we have to go with the population association. Like COVID data, diabetic patients having more risk of having COVID, that's a regression outcome only, indirectly, because the larger populations are being matched, and then they compared with what is the risk of among the patients who are arriving at the clinic, hypertension, diabetes, COPD, lung diseases, and the major cofactors, comorbid conditions. When they analyze it worldwide, most of the individuals having these 4 categories. So then we don't need individual level data. We need a population level data. Then regression is perfectly can be used. That's the reason. So the associations, when we need what exactly we need to use that particular technique. So all techniques are needed whenever the situation emerges. Hope I answered. If not, feel free to ask the question again if you have any more.
Yes, sir. Thank you, sir. Yes.
Excuse me, sir.
Yes, ma'am.
Sir, how these modeling help to control the hepatitis C?
Yeah. Go ahead.
What are the objective of doing all these modelings?
The objective is how better we can understand the network among the injection sharing populations. How best we can reach them, and what are the better ways to control, because our end goal is to control the spread. Like HIV, other day you saw the controlling the spread. Controlling the spread. So these models can help to bring the government policies, better policies, so that they can be reached the population, those who are in need. Like HIV population, similarly the transmission, prevalence, we have to reduce the prevalence. Prevalence ko kam karna hai. Network, reduce the hepatitis, reduce the prevalence in hepatitis C, sharing the needles. Also, you have financial burden, a lot of money being spent by the youth unnecessarily. So the aim is to break the networks. Once you understand the network, you break it. Try to counsel them, identify them, counsel appropriate people, those who really follow, those who have a network. So identify right kind of networks.
Okay, sir. Thank you, sir.
You're welcome. Yeah, you all need on. That's the reason which kind of things to apply. You need to know the total things available for you to understand them, and then use them in a right way, right kind of time. When you need mathematical model, apply. When you need graphical model, when you need stochastic model, when you need statistical model. The aim is here to help or assist the public health or the medical community to in their own, because they won't know what kind of thing they approach as a modeler. You decide what kind of things are appropriate. Any more questions? Anything, feel free to ask regarding modeling, because this session is about the epidemic modeling on the data. Data-related questions, modeling-related questions, all feel free to ask me. And then other articles on HIV you all must have received. I sent the models. So there also you read after the GAN program. I know this is a very intensive program. You all been really following well, as yesterday Professor Kumar mentioned. Attentively you all going through the course. And you all now, I'm sure, based on the things, interactive sessions, you all really understood what has been taught over the last 4 days, the methods. That is enough for you all to have a self-study, because it is never ending. Learning is never ending, but the foundation is strong. One can have a self-study, further self-study can be done, and then one can connect it well. When you go to the conferences, when you go to the meetings, you can connect the language very well. What's happening, language, not the English or Hindi versus Haryanvi, no. The language of technical language, you can interact with them. When you're thorough, you can train another clinician or doctors and non-technical background and explain them. When you explain the things, complicated things more easily, then only your work, automatically they understand what you are speaking. Yeah. Any more questions?
So, sir, are there mathematical models available for this HCV modeling, models based on the differential equations?
Yes, differential equations are like HIV, differential equation model also done in HCV also.
So might be a variation of SIR or SIE.
Yes, variation SIR. Yeah, that's what they give a population level information, not individual level.
So sir, what prompt you to go for a different route when the mathematical models are available? Probably they may give better information.
Correct. What happened was, as you know, that I have been working with various, the practically implementable, like HIV model. You saw practically we tested and implemented. That's the reason CDC and Center for Disease Control, like our ICMR, in the USA.
Mhm. Mhm.
They when they asked me to know that it is there, I want to thank them. To when they approached me to build mathematical models, and then I suggested when they approached me, they didn't come up with you have to build certain model. No, this is the problem we are facing. Still, the whatever maybe the interventions, the still they are unable to reach the right kind of people to control the epidemic. What kind of then I and by that before this I as I mentioned I studied the chicken walk. I developed the chicken model, something called chicken walk model, the birds transmission in the among the birds. So they
Mhm.
saw that, and then that has been successfully implemented other parts of the world. At the time when they approached, I thought this could be more appropriate. Then once I published that, others uh, studies appreciated in their articles about this new framework,
Okay. Right.
and ultimately they have to agree. It is that if we are to prepare to change the methods depending on whatever needed.
Mhm.
For example, the roadway construction in India I mentioned other day,
Mhm.
the sustainability of the roads, because India the roads have been built now with a rapid speed, highways have been built. The
Mhm.
question raised from one of the civil engineering groups in IITs asked me, can we build any model for sustainability of the roads in India?
Mhm.
So there I built partial differential equation models, partial using the partial differential equations, and then taking the various factors into the road, the what kind of materials, various things, the in the discussion among the civil engineers. So we
Mhm.
built a model to understand sustainability of the roads using the partial differentiation, and then the index. We developed an index for the roads to decide what is the quality of the road and what level of sustainability is there on the roads. So depending on the problem to problem, we need to be, we need to be ready to provide solutions.
Right. So, thank you, sir.
Welcome.
Any other questions from the participants?
Sir, since you are here, so I would like to ask one more question.
Please.
So when I see those very difficult and mathematically rigorous PDEs in the papers to understand a phenomena, say diffusion phenomena or a transmission phenomena, so how to understand those PDEs better? I mean, would you like? I mean, can you recommend a suitable reference for the one who is not from core mathematics side to understand those PDEs?
PD, lot of books are there, by the Indian authors. There are several very, very good books. One can have internationally also. A lot of books are there. There is a book by Dr. Nigam.
Okay.
Nigam, and another book by Amarnath. Amarnath, the authors, the PDE is on PDE. It's a small book.
Uh, okay.
And
By Dr. Ramannath, right, sir?
yes, Dr. Amarnath one and Dr. Nigam. That book, I think they wrote together or they wrote differently. I taught one of them. When I taught differential equation, I think I followed that book also.
Okay, okay,
Yeah,
yes.
a lot of good books are there. India, from India, a lot of good textbooks
And,
are there.
and it is only by the Professor T. Amarnath. Yeah,
Yeah, I think the initial maybe I forgot. The initial maybe yes, Yamarnath.
by Nerosa.
Narosa, yeah, Naro, you're right. It's a small book, 200 page, less than a 200-page book.
Yes, yes, yes.
Many other books are there, which are very good books published from India. Yeah.
So, I guess the questions now, no more questions from the participant side, I can see. So, we can take a break of 15 minutes and
Okay.
then we can resume back.
Sure, sure.
10 minutes or 15 minutes, sir? 10 minutes?
10 minutes. Okay. So after the break, I have
Yes.
two plans. So should I come up with, should I speak on, because the next session also, sorry. The next session is also public health. Should I
Yes, sir.
give a tutorial, give a talk on the training on the COVID, or you prefer continuation network model? Network model. आपको क्या दोनों में
I guess on COVID it will be fine, sir.
COVID will fine? Okay. So I
Yes,
will
sir.
explain on the COVID model. COVID model will go like this kind of network model will go step by step on that.
Right, sir. Yes. So after 10 minutes, we will
10
resume
minutes.
back. Yes,
Sure.
sir.